Welcome, everyone, to our webinar this month, presented by myself, Udzai Manditeresa, and Shashank Sharma. Shashank, could you please kind of like just give us a quick introduction?
Yeah, thank you. And yeah, welcome from my side as well. So I'm Shashank, and let me actually go and I'm like change the slides. So a quick introduction about myself. I'm Shashank. I'm director of product marketing at HiveMQ, and today I am co-hosting the webinar today with Kutsai. I have a background as an engineer, and I've worked in engineering and tech sales before joining the product marketing. My background is mechanical engineering and computer science. So the problems that we face in Industry 4.0, I'm familiar with them. And today I'll be gladly playing the role of the host and drive the conversation with our expert, Kodzai. And Kodzai, I would like to hand over to you and tell everybody who may not know you to like give the introduction and why you're the subject matter expert. And then we move towards and start our webinar today on the topic why intelligence must be distributed and not centralized. And today we'll learn a little bit more about that.
Absolutely. Thank you so much for the introduction, Shashank. My name is Gutaiman Teresa. I'm an industrial solutions advocate here at HiveMQ. And as Shashank mentioned, I take care of most our thought leadership around topics of smart manufacturing, industrial AI, agentic AI, and more importantly, the topic of discussion today as well, distributed intelligence. I've got a background in industrial system integration, having worked on the shop floor, previously. Kind of like I've got a more, a deeper perspective into the problems and challenges that goes on in the shop floor. So I'm really looking forward to, spending some time with you here today and explore this topic together.
Thanks, Kutsai. So let's dive into it. So I think like the most common thing, why are we doing this? What's the reason to do any of that? Why decisions are moving to edge? So I think Kutsai, just from very high level point of view, we are hearing a couple of things, right? Like there is a competitive pressure on responsiveness. There are some regulatory drivers. There's some supply chain volatility that's happening. Being very well connected with a lot of folks in this field, what are some of your observations? Like we have written some stuff on the slide, but in your words, what are you seeing right now, and why decisions are moving to the edge?
Oh yes, absolutely. Yeah, so I think we're seeing more and more companies starting to look at bringing intelligence closer to the edge, and we're going to talk about what's been sort of like the traditional approach before of centralizing data, but I often like to bring up this statistic in this regard, where the U.S. Bureau of Labor Statistics highlighted that the total factory productivity in manufacturing from the period of 2008 to 2023 has been flat, and at some point in time it also declined, right? And that is staggering, right? At least in my perspective,
That's
because
crazy. Yeah.
that is it's really during that same time where we've seen a lot of investment as far as industrial IoT is concerned, in installation of sensors, deployment of MES solutions and other digital systems on the shop floor. And this obviously tells us that there's something else other than just surfacing data, other than making data accessible. So data access was really not the bottleneck there, because if it was, then we would see at least a tick in productivity, or for sort of like an upward trend. So what this means actually is that the bottleneck is more when the data is surfaced, what actually happens, after the data is surfaced, right? The diagnostics that needs to happen, the reasoning, the decision making that needs to happen, right where that data, is being generated at the edge, right? And I think, this is, Shashank, some of people, would call that a decision intelligence gap, or decision latency gap, as it
Yeah.
were, whereby really data is not being turned into information and insights, and obviously decisions fast enough to keep up with the problems that need to be solved to make sure that we keep up with the productivity that is demanded. And again, just based on also what you mentioned right there, or also what you see on the screen there, as far as the reasons for that is concerned. So there's many different reasons, but mainly there's just not enough, obviously, skilled people to fill that gap. People who can look at the data and turn that into information, turn it into decisions, so that we can act on the data in real time. And also, again, the markets are demanding more flexibility and adaptability. I mean, if you look, for example, if you had a line that used to run stably, like a stable line that runs maybe making 1.5 liter bottles of product, it's not uncommon now to be required to change that overnight to make 1 liter or 500 milliliters. This is something that the traditional landscape or the traditional model of using data to solve those decisions of this variance is not, the traditional architecture was not built for that kind of flexibility and adaptability demand. And because of that decision intelligence or decision latency is becoming more of a competitive metric. Like the companies that are able to actually fill that gap are the ones that are able to address those market demands, those competitive pressures, those regulatory compliance. So this is the reason why we're seeing a lot of interest in actually moving intelligence at the edge, so that those data can be turned into insights, into actionable decisions in real time, as opposed to the other way of centralizing the data and kind of like increasing the time that you can actually turn that into information. So if I was to summarize this, is that we, or rather companies are no longer it's no longer enough rather to ask do we have the data, but you also need to ask how long does it take for that data to actually become a decision, and how long before that decision actually changes what is happening physically on the shop floor.
Yeah, no, thanks for walking us through on this, Kudzai. So, like what I'm hearing is it's not just market pressure or demands from like, your end consumer that is changing this pattern. There's also like different factors coming in, regulatory, supply chain factors, or sometimes people are turning constraints into a competitive edge. Like you gave a very good example of changing what you build on the production line overnight. And these kind of things require high flexibility, and that means you also need data, like get data so that you can act on it fast, right? So, and that's where I think we are. This whole webinar is also placed. So I'm going to give, before I hand over to you, like we hear like about this playbook, and if you think a mental model in your head, how would you use the data? Uh, the the data is that, oh, I'm going to collect everything, and this is what you mentioned, and people also mention, right? Like they think about collecting the data, then I'm going to send this somewhere, and then something magical will happen with the analysis and we'll get some magical insights, right? So this the playbook has been, let me collect and send it to a central place. What do you think about that, Kutsai? Like especially like you talked a lot about challenges and what's happening in the market. What's your opinion on this playbook still, and how do you look today on this?
Yeah, absolutely. I think that's a good point. To really understand why sort of like intelligence needs to become more distributed. So obviously it helps for us to look at what sort of like the architecture shaped the last decade, or what is the
Yeah.
architecture that a lot of companies already have in place. So as you mentioned, that playbook was that you collect data, right? You centralize the data and then you analyze data. So this is whereby companies collect data and they move it into a central warehouse. So initially it was data warehouse, and then we had a data lake, and then we had a lake house. So but still the concept is the same, that you're getting all of this raw data and then you're centralizing it, and then once it arrives there, You then use some reporting tools, dashboards and analytic models to then, extract, the
Mhm.
insight.
So I want to give like a fair shot. So I would like to ask you here, like, what are the use cases where this model works still today? And it used to work well in the past, and it still works well today, right? Because there must be some areas. So what do you have to say about that? And which are the areas, like where is it failing like that? Can you like a little bit go a little bit on that?
Yeah, absolutely. And I mean, to be clear, this approach obviously delivered, enormous value as far as data-driven optimization is concerned. It sort of like gives organizations a consolidated view of
Mhm.
performance, and then it supports, enterprise reporting, benchmarking, and things like that. So mostly for, business data, right, where, decisions could be made over, hours, days, or weeks. That works really well, right? And but however, when you go into more operational decisions that we highlighted earlier that need to to happen in real time, the reality is that the usefulness of information can change very
Mhm.
quickly. So if you
Yeah.
get a signal, you need to turn that into information, turn it into insight, and then you can act on that in real time. Because if it's like sometimes even a second later, that may not really be a useful signal to have. And talk about seconds, talk about minutes and hours. But the traditional model is such that when you have a problem to solve or a use case, sometimes you need to take it to your data team, central data team, data scientist or whoever it is. And then in many cases, they have to sort of like go through the contextualization of the data, building up your use case. Sometimes even those data engineering pipelines, they sort of like run on a 6 hourly or 24 hourly basis. So there isn't that real time access to insight that you
Mhm.
actually need to be able to perform on the shop floor. And also the central data team also quickly becomes a bottleneck, right? Because you the only way you can actually get returns on data investment at scale is when every stakeholder within your operations is able to turn data
Mhm.
into information, right? So obviously, if you depend on the central data team to actually generate those insights, so that team is also, acting as a bottleneck, as it were. So, but the bottom line is that by the time the data is transported, normalized, processed, and then made available to you, that window for that best decision that you needed to take may already have passed, right? And
Okay.
yeah, and also another thing to mention here is that there's also a difference between insight and action, right? So when you sort of like in a centralized system, you know, tells you that there was an excessive vibration at this line, during a
Yeah.
previous shift, right? And that is useful, obviously, for root cause analysis, reporting to see what actually happened,
Mhm.
yesterday. And I think there's one industry veteran who likes to call them we sucked yesterday metrics, right? It only tells you how actually
Yeah.
you performed yesterday, right? But the
Yeah.
operation really needs you to reroute production within
Mhm.
those minutes. It requires you to inspect a component. So obviously that becomes a challenge with the centralization of intelligence when that comes to that.
Mhm. Thanks for summarizing it so well, Kudzai. So I understand anything where you need sort of hindsight. The centralization is a really good approach, but if you want to act in the present tense, then probably it's not the best approach.
Yeah, absolutely.
Um,
And also, just to add, obviously, these two, obviously, as you will see later on, these two obviously approaches, they work, hand in hand, whereby you still have a way to, to govern the data, perform
yeah.
long-term optimization and things like that, right? And I think the analogy that I also, like to use to say, manufacturing operations for you to keep up with the demands of like those minute decisions. It's more like having that wearable device that gives you those events in real time. When you get a sugar spike, you need to do some, corrective action when you miss something, but you still need to go to the doctor at the end of the year,
Doctor.
that
Yes.
milestone review. So that's kind of like those analogies that I could use there.
That's a great analogy. I think everybody can relate to that. So let's talk a little bit about AI and models. And like we hear a lot that I did a POC, and then like in my sandbox, my model was working perfectly with all the data, and then I implemented this, and then it breaks, right? There are multiple reasons. How does it break? And also, I think like the centralization model, if we look at not just AI model, but the centralization model of collect, centralize, and analyze, how does that break in the plant flows?
Yeah. So I think there's kind of like, two models, kind of like look at. So there's the model, right? The model of really, centralizing data, and the actual model, AI model for,
Yeah.
performing inference. So when we talk about the centralization model, and if you look at, different ways that, shop floor operations, stakeholders need to be able to, make decisions. First of all, obviously, they need to get that visibility into whatever is going on. So, right, that first, line of, of intelligence is that visibility. And in many cases, that intelligence is just not there, right? It's not visible. So if you are, an area manager, plant manager, you don't have that, visibility onto how are you currently running right now? What is at risk? Or what is the risk that if that one goes down, this thing happens, and so on. So you don't kind of like have that view as it were. So in most cases, problem solving on the shop floor, turns into, an approach whereby you are working through issues in the order that you notice them. So if this,
Yeah.
equipment goes down, you go and fix it, you do that. So it's more, of firefighting, but obviously you could benefit more from any intelligence that kind of like gives you a broader
Yeah.
perspective into exactly how you are working. And also, if you don't have visibility into the impact, you could obviously, end up spending too much time fixing something that does not necessarily, cause the greatest, financial damage, or, the greatest regulatory risk as far as that is concerned. So I think that's the first issue, that just to get that visibility in real time. If you're sending all of the data into the cloud and kind of like waiting to then, contextualize it and turn it into information there, then obviously you lose that first line of being able to be visible. And then
Mhm.
the second point is that if in cases where you do have that intelligence using that, centralized model, is that it's too late to act. I think we mentioned this idea that yes, intelligence may come, but it may already, be, too late to act, because in some cases, if you want to sort of like turn data into information, it may require you to sort of like combine information. So whether it's from ERP, you're pulling data from the historian, you're pulling data from that, maintenance system, or maybe some of it is MES. And by that time that analysis is complete, right? That shift has ended, or the batch is finished. So you
Yeah.
already missed that opportunity to course correct. So again, centralization. If you have then a decentralized approach, which you are obviously going to go into more, that is, continuously pulling all of this information, continuously contextualizing it, and continuously making it accessible to the operators, then you have information that is timely, that allows you to solve those problems
Yeah.
as and when they
Mhm.
happen. Yeah, and
Which I
also
also heard. Oh, so please continue. I think like you had another point.
Yeah, I mean, so I was going to talk about more the issue of the lack of domain, context, because as some of you who work on the shop floor, know it's the people who actually on the shop floor understand. There's physics obviously behind what's actually happening on the shop floor, chemical processes,
Yeah.
and the machines and things like that. So the people who actually understand the physics behind it are in many cases the people who are best positioned to actually do the contextualization of the data,
Mhm.
to first and foremost solve their own problems, right? If they want to solve their own problems, they want to, generate events, they want to generate workflows that happen after any certain event occurs. These are the people who understand that. And ideally, you'd want to do that, first approach first, and then aggregate that data into a central warehouse where then that could be useful for business,
Mhm.
applications. But in many cases, with
Yeah.
the centralized approach, it's the reverse, whereby the data is raw and it is contextualized in the data warehouse on the central, data team, and then that information is, made available back to the shop floor. So in some cases, it may not be something that is relevant to what the actual expert needs to solve,
Yeah.
that, problem. So there's that
Mhm.
gap between who actually gets to do the, the contextualization. So that's why obviously with, distributed intelligence, with the tools that allow you to distribute intelligence, they come in also with the ability to make available
Yeah.
the tools to contextualize data right at the, at the shop floor where you have got those experts to understand the physics behind it.
Exactly. And let me share one anecdotal example that I've heard. So, in this case, lack of domain context plus central team data becoming bottleneck. I was recently at a conference where a lot of manufacturers shared the similar issue. So, the challenge is they usually have a data team, which is a central IT team, and they take care of the data pipelines, but usually inside the data, as you suggested, right? Like they're not the experts on what that data means. And the challenge becomes that your subject matter experts sit on the factory, and when they request data, the data owners will ask what data you need and will send it to you, because they're just gonna query and send it. But then the other guys, they don't have the full picture, so it becomes a very iterative and cyclic and a little bit frustrating process where the subject matter experts do not have the access to the contextualized data, let alone in the real time. And it takes quite some time to figure that out process. And every time there's an issue, there's a high likelihood of such a interaction repeating. So this added another. It's not just centralization; it's also like the unclear roles and ownership of the data, which causes more problems on top. Is this a fair statement?
Yeah, absolutely. And I mean, also to kind of like add on that, it's a this approach also. I mean, we talk about this idea of silos. I think everyone on this call already has had too much information about data silos, but that's exactly what this approach does. It sort of like perpetuates these organizational silos because for each use case that you're addressing at the central location, it means that you're standing up a data engineering pipeline, as it were, that is built specifically for that use case. And then maybe again, some
Mhm.
obviously data scientists may create a view that is dedicated to
Yeah.
what they are trying to solve at that specific moment, that is not available to to anyone else, right? To reuse. So it also perpetuates this idea of organizational silos and also complex architecture, as it were. And then obviously, for a lot of you who have been, following us for a long time, you know that we really talk more about uh, decoupling, right? That distributed intelligence comes more with decoupling. That as intelligence is generated at the edge for solving problems on the shop floor, it is also made broadly accessible, right? That information can be reused for something else from some other use cases that allows you to really scale your and get more return from your data investments, because it means that all of this data is not being repetitive. You're also not perpetuating these organizational silos, as it were.
Yeah, no, thanks for adding that, Kudzai. That's definitely on truth. And moving ahead, like to this discussion, now we are talking about, okay, we need like something on the edge. Centralizing everything is not the answer. The question then governs that, okay, how should we think about what's the mental model, right? Like, do we still, and you also mentioned this, we still need to send some data and collect and centralize it. So we are not actively saying that do not do that. The question is mental models, right? Like, so what's your take on that? What's the fix here?
Oh yeah, absolutely. So again, it's a I would kind of like reframe it more as a top-down to compared to a bottom-up approach, right? So with the top-down, basically the idea that you're going to have experts who are going to sit down and also try to imagine what are the different data products, for like for better word, or insights and all these different models that may be required to actually run efficiently or to for quality assurance and all these different things, which is fine, but obviously it's not scalable, right? Because there's no obviously one person who actually knows what's actually happening on the shop floor. The shop floor is messy. The decisions need to happen in real time. And the other approach is that bottom up approach, whereby you make those tools available on the shop floor for the experts to get the data that they need first and foremost. Again, as I mentioned, to solve their own problems, and then once you want to then make that data available for the business, this is where you then come in from the central data side and say, hey, we need to actually define standards here, and by standards, not no strict comprehensive standards, but rather loose standards, more abstract standards and KPIs and metrics that allows the edge to extend those and customize them for their own solutions and then expose them back again. So that kind of like gives that flexibility. So the decentralization does not necessarily mean that you don't have a central data platform that is still there, still plays its parts, again, as I mentioned, for long-term optimization, for more business use cases. And then on the edge, for sort of operational domain, you have this distributed data intelligence, where intelligence is actually pushed right down to where people are doing the work, where data is being generated, and where all these problems are arising in real time and need to be solved minute by minute. So it's a more of a hybrid approach, I would say.
Okay, thank you. And I think like the slide also summarizes what we've been discussing in last two or three slides as well, right? Just to summarize, like the centralization thing, like we talked about, latency is too high. The moment to act on the data usually passes, so we can't rely to have a centralization approach on operational data, right? And also because the data loses meaning the farther we try to contextualize it from the where it's produced. Best practices is to contextualize it closer to the edge. And if you do it centralized, then it has a lot of downstream impacts. And obviously, you can't add like a really good context far away because it loses meaning. So, so here, let me ask you. So, what do we actually propose here? That's what would you suggest?
Yeah. Yeah, and I think we've kind of like sort of like alluded to it throughout the course of this webinar so far. But basically, the idea is to say you do not centralize data. You do not take the raw data from your machines, your PLCs, and put it in the data center or data warehouse in its raw form. It will ultimately end up there, but it needs to go through those stages where, first of all, you do that connect phase where you're connecting on the to the machine. You're setting up that connectivity infrastructure. You're converting that data into a protocol that allows you to distribute it widely. So because obviously if you're going to be using that data for multiple use cases, you want to standardize on that common format of the data and in the common way in which you actually subscribe to receive that data. Decoupling approach, I think we speak about that a lot, because then that allows you to onboard as many as much equipment or machines into your digital infrastructure for AI as possible. Again, we talk about this idea of saying you don't need to connect systems directly to each other to create this point-to-point interface, because then it sort of like makes it difficult and hard to scale and slow for you to be able to onboard those pieces of equipment. So that's the first stage, and then the second stage is that you want to be able to then context that data again at the at the edge to turn it into useful information, and then be able to create those analytics, those continuously running analytics, not analytics that needs someone to go in to pull the data, but rather something that you can actually define and configure, and then you have got a continuous running application that is at any given time telling you how you're performing or giving you whatever metric or insight or intelligence that you need to sort of like nudge you in your daily work to perform better, to investigate and do things like that. And then ultimately, obviously, a lot of companies are starting to look more into, say, we talk about this idea of a decision intelligence gap. We spoke
Yeah.
about this idea of a decision latency, and I think that's the reason why, although it's still early stages, but that's the reason why a lot of companies find agentic AI useful, because it allows them to sort of like replace those non-value adding tasks that still
Mhm.
require skilled people to perform. So it's still pulling away from that uh, you know you know uh, you know you know cognitive capability to do some things that can actually be automated using agentic AI. It could be things that are non production critical, whether it's preparing an after shift report or things like that, that still to this day require someone who actually understands what's happening there. So once you've done that aspect, you then make that data available. You're creating that semantic backbone that allows you to then build those, or rather deploy those AI agents that allow you to not only surface intelligence at edge on data on the fly as and when it happens, but also to some extent perform a close the loop by acting on that. So again, which is either you know performing an after shift report, doing a root cause analysis on what actually went bad or what went wrong about that. So this is basically what we're sort of like advocating to push data to the edge and ultimately make it available for integration from a high level perspective from a central data platform. So I think if you kind of like maybe go on to the next one, we sort of like look at how that looks like from at least from HiveMQ
Mhm.
perspective architecturally.
Yeah. Okay. So can I, before we move on, can I just repeat in simple terms what you said? And like I learned three things. The first one is you do not treat your operational intelligence same way you treat your IT intelligence. So you built it for real time, right? So you create intelligence for operational intelligence at the edge where you are pulling in data, contextualizing it close to where it's being generated so that data has meaning. And then you centralize things that are still worth sending for aggregating and like long-term historical purpose, but you make use of all the operational data right at the edge and make it work. And there is a value in centralizing things like governance, for example, across the company or across the org, but then the other things need to be distributed like edge intelligence or operations at each line or site. Is this a fair, accurate summary? And then you also mentioned about agentic, and I think like this is the basis for the agentic because you need to make sure that the data is trustworthy for coming. Like if you want agents to act on it, and your quality of operational data depends on your context and how well it's contextualized with the right context. So all these makes me think that okay, you need to have a way to have like data coming in and making it work for the operational intelligence, not rely on completely on IT to solve this problem for you.
Yes, absolutely. And the takeaway there obviously is that data is valuable like on the fly. You need to turn that data into information, into analytics, into actions while it's actually in transit, right? While it's actually
Mhm.
in transit before it actually goes to rest. So that's kind of like the key insight there.
Mhm. No, amazing. So you mentioned an architecture. I think people are excited. So before you begin here and explain what this structure is and how it relates to what we've been talking about so far, I do want to add the concept that if there are some new people here in the audience, there is a concept of unified namespace, and unified namespace is an information model on how you organize your business data across your org for like real time, uses. Because I think like this is a very short definition and very quick and dirty definition that I just gave on UNS. But I thought like I'll just call it out. I also see a question in Q&A about the org model. So yeah, I wanted to baseline it, and now I hand it over to you to please walk us through the concepts and like the architecture and what we see here. It looks very complex. So yeah, so please walk us through.
Yeah, absolutely. So, what you're looking at here is a more, high level overview of, the different, layers, as it were, of the, industrial data architecture, where you have your machines, and from there, we spoke about this idea that first and foremost, you need to obviously connect to those systems and get the data out. So this is where you see we've got HiveMQ Edge, which is a software that allows you to connect to multiple protocol adapters, things like OPC Modbus and BACnet and things like that, and then convert that into MQTT, so that you've got that consistent data format and consistent way of distributing that information. And then within HiveMQ Edge there, you can then organize already that information into a structure, sort of like a consistent structure, and sort of like a unified namespace that is localized, to that specific environment. So if HiveMQ Edge is, positioned at a certain line, then you're organizing that information, and that is obviously the first point of just making data visible, because you're pulling it from many different machines. You're organizing into a semantic, hierarchy and structuring it just to make that data visible from one point location, instead of you needing to go to all these different systems. And then, as you can see, there we've got sort of like that pulsating icon on the HiveMQ Edge that shows that also you're able to, at that specific point, push your intelligence right there, where you're able to act on that data right at the point of generation. And the definition of that intelligence happens obviously onto the right side of things, where you're able to then kind of like just define it and then push it so that it is executed right there at the edge. And there's things like Data Hub, as you can see, that allows you to do validation of the payload before the data actually hits your central data lake and things like that. And then you aggregate all of this information that is being pulled from PLCs into that one central broker, right? Typically, this would be like a site-wide broker that aggregates all of this MQT data into that one unified namespace that Mr. Shank alluded to at that site level. So there you're making data visible site-wide, right, in a semantic hierarchy. And then still with that data that is still being generated dynamically on the fly, you're also able to apply that intelligence. You're able to define those analytics, those continuously running analytics for them to be performed right there, and that data is accessible to whoever is connecting to that information, whether they're using a SCADA system to subscribe to those intelligence, whether they're using something as simple as a Node-RED application, they're using an analytics application, whatever tool. The idea is that it's now more of an open ecosystem that allows anyone to get access to intelligence right where they're actually performing that work, that intelligence that is being generated, or those long, continuously running analytics, as it were. But obviously, again, as we mentioned, it doesn't end there. Data still needs to aggregate to your enterprise-wide. And bear in mind, this is really still your real-time data. This is still your real-time backbone that cuts across your entire enterprise and pushing all of this data together. And one of the big challenges that companies come across already when they create this data backbone is that obviously if you allow people to then publish contextualized data, and then it can quickly become that mess that we spoke about. So you need to have a way to govern that information model to make it useful for your business application. So this is where on the right side of things, you're then able to say, this is what from an enterprise or organizational perspective, we want this model to look like, so that we've got that consistency, so that we can be guaranteed that our business applications depend, or we depend on this data to actually make business decisions. So you need to have that governance capability. This way you're able to do that on the central data side of things and do those intelligence, and still be able to offload that highly contextual data, those analytic products into a data warehouse, into a lakehouse, into a data lake for that long-term optimization, or for whatever business so goals that you want to achieve. But the point is that you've effectively replaced all these disconnect data engineering pipelines that you typically have addressing different use cases. Now you've got this data foundation, a common backbone to which you are plugging your central data application. Your central data platform is now tapping off of one, organized, governed and consistent data model, already contextualized data, and then sort of like cutting that time to value also on the business side of things. Back to you, Shashank.
Thank you, Coach. Yeah, thank you. I think like one of the very important things that I find like very mind blowing about this whole architecture is that the data is being processed at the edge and it doesn't leave your factory floor. So being able to do it while controlling centrally, I find the whole idea amazing because it balances out the data sovereignty of like a factory floor very well by a corporate governance policy that needs to detect certain things. So yeah, like that's my favorite part. There's a ton of things that you walk through. So just calling out one thing out of 10. Uh, Now let's talk about, oh yeah, Kudzai. Do you want to add something?
Uh, no, I think we can move on. That's
Okay.
fine.
Okay. Oh, great. Yeah. So now, what we want to say is like we are not saying all this in air. So let's talk about what our customers are doing. We'll talk today about three customers, like how Ford is saving money by like decreasing their production downtime, how Lilly achieved almost five nines and compliance grade reliability across 15 sites, and then how BMW went from 30 seconds to open the car door with their app to less than 1 second across 20 million vehicles. So all three of them have HiveMQ as like a reliable common denominator, which is helping achieve this outcome. Specifically, I'd love to talk more about Ford and Lilly in the next two slides. Do you, Kutsai, do you want to add something here? Do you want to, like, what's your point of view? Are you also seeing, in addition to what we are showing on the slide, some similar things with other customers as well?
Yeah, I mean, we just maybe to sort of like emphasize on the scalability aspect of it. So if you look, for example, Lily, if you look at the case study that we've got on our website, there you realize that they actually started with onboarding their laboratory equipment, right? So onboarding their laboratory equipment just to meet those regulatory
Yeah.
requirements of moving away from pen and paper. That's just one use case. But then this allows them to move on to the next use case, and to the next use case, and the next use case,
Mhm.
all on the same data backbone. So you're not it's a reusable data foundation that allows you to recreate all of these use cases, or rather
Okay.
readdress all these use cases.
I think it's worth diving then into each of these use cases quickly. So let's first talk about Ford. Ford uses HiveMQ in their smart manufacturing operations. They're solving the problem of real-time visibility, and they're enabling real-time visibility and consistent operational visibility across their global factories with a unified data architecture, which is built on the concept of unified namespace and a top HiveMQ platform. So like what are the three driving pillars? So one is standardization is very important driver. They want to unify machines and plant data across all the sites. They want to monitor centrally, yet like keep the autonomy at the plant level, because they want to ultimately improve fault detection and reduce time. And yeah, and then they want to make sure they are able to understand when failure happens based on the data available to them. So creating a predictive maintenance and faster rollout for digital initiatives. So that's where we are helping them, and like we are helping them save 24 million every year. And then Kudzai, you also mentioned about Eli Lilly. So Eli Lilly is a digital factory initiative. We started out as a compliance use case, right? You mentioned this, moving them from pen and paper to like a digital audit trail, and this helped them unlock new use cases. And now this helped them build also a unified namespace across 15 sites, and they have a lot of connected instruments and all this optimizations, not just from one use case, but this multiple interconnected use case are helping them solve a lot of savings annually. And obviously, moving the uptime reliability also helps them save that, because they're having much less downtime, operational downtime. Kudza, you have been obviously involved here like a little bit. So do you want to add anything to what I said, or?
Yeah, and I think you pretty much covered the whole overview of it. Yeah, but just really to emphasize on that scale issue, the ability to scale. That's the biggest bottleneck that a lot of companies face when they start with one use case and then it works. So you've got everything connected directly to each other. But the moment you want to then move on to the second use case, this is where you realize that you actually need to do another investment in connectivity infrastructure, which
Mhm.
is only not expensive but also slows you down as far as addressing the different use cases is concerned.
Okay, and it also kind of builds more point-to-point connections, right? Which is an anti-pattern.
Yes, absolutely. Over time, then it kind of like again perpetuates these silos that already exist within your manufacturing operations. So you're still getting the data, but still you're perpetuating that silo, which is going to slow you down eventually.
Agreed. So, Jose, let's talk about the summaries, because we talked about the problems, we talked about an approach, and we talked about some customers that we have helped with that approach. So how you gonna? What's the takeaway for like the people or the audience that are here today?
Yeah, so I think the biggest takeaway is really looking at what problem from an operational perspective needs to be solved on the shop floor, how to enable people on the shop floor to solve their day-to-day problems, right? And so that obviously involves making the data visible first and foremost, making the data understandable. Secondly, making continuous analytics that turn data into intelligence, right? And then also making it possible that you can actually then apply some advanced AI capabilities in places where you can actually replace some non-value adding work, or you can offload non-value adding work from your SMEs to something like agentic AI that can really help you to get more return on your data investments. And so move that data to that intelligence to edge really is where that is about, where the data is actually being generated and not moving the data first onto to the cloud platform or central platform to then start to figure out what to do that data with on that side of things. So you stream the data. This is what it does. You build the intelligence, and then you activate that AI as the slide portrays them.
Okay, no, very well summarized, Kudzai. I wouldn't have said it better if I tried. Uh, I think like one question that begs is like, how are we doing this, right? So there's a lot to say, but I think Kudzai and I want to give you guys a short summary today. So, Kudzai, please, how would you briefly walk through how we do that? Like you mentioned, like stream data, build intelligence, and then activate AI. So, like if you have to put us in the same lens, then how would you do it in very short, very summarized way?
Yeah, absolutely. I mean, for those who are familiar with HiveMQ and some of our customers, they would know that we've always been a data streaming company, right? We've built products for data acquisition, data integration, and this is what we've done since 2012. So we've really been doing for a very long time, and so what that has helped us do is that really build that nervous system across many different industries, from manufacturing to connected cars and things like that. And then obviously the natural next step was to then say, okay, but how can we help companies turn, not just distribute data and not just make sure that data is highly available? How can we get a step closer to actually turning data into information? This is where we then build, data intelligence capabilities, which is a layer that sits on top of the, our MQTT data streaming real estate. So if you remember from that architecture, this is the layer that does that, that enforces that consistent model across all of these different. So if you've got HiveMQ Edge, HiveMQ Enterprise, and all these different pieces of real estate that are scattered across your enterprise, you need a way of then consolidating them or creating a consistent information model that you can define at a enterprise level, but have those analytics happen at the edge. So that includes the data catalog to find out what data is being published, where data models, defining what the data structure should look like, and governing obviously the data, doing some validations of the data, monitoring the data lineage, where is the data originating, and so on and so forth. And then under the hood, or basically kind of like creating a semantic graph, because the unified namespace that Shashank mentioned earlier, what it does is that it creates obviously a semantic hierarchy. But for agentic AI and other advanced capabilities, you want to be able to also reflect the graphical connections that underlie these data points or these machines. So this is where we've got a semantic graph that links all of these, so to create what typically you'd call a knowledge graph. So you create that ontology first, and then you sort of like instantiate that as a knowledge graph, which is what our semantic graph is effectively. So that keeps your agents grounded and allow you to be able to create those harnesses or guardrails that you can you can safely delegate your tasks to agents, because they're working off of a model that you've defined, right? And
Yeah.
then speaking of agents, we then have that layer on top that allows you to then build those agents and kind of like perform inference, analytics, and also do any kind of oversight or human in the loop kind of like operation that you want to be able to do. So basically, we're moving from this proven, solid, data streaming backbone, and sort of like going up the stack to provide you with the capability to actually turn data into information and in action ultimately in the shortest amount of time possible.
Thanks, Kotsai. I'll just add couple lines more on top. I would say that in the next webinar, we will talk and dive deep into how HiveMQ does all these three things. And then what parts can you do this like details like via distributed way, and which parts needs to be centralized. I think this is like the whole theme of discussion here. So please keep an eye out on our September webinar. We'll be taking a break in August. In the September webinar, we'll have a deep dive into our new HiveMQ platform and all these three layers. So
Yeah.
from my side, I'd like to thank you for listening so far. Kudzai, we have a few questions, so we can probably address. a little bit of them.
Yeah,
Let me
so
start and ask you the first question. So I think like one question just popped up recently, and I think like let's address this one. So Helen Rodriguez say that for me, it seems that the presented architecture still points to centralized intelligence, and for you to have intelligence at the edge, you would need the persistent layer, processing layer, etc., not at the cloud or data center. I think this is worth dissecting. So I do like start this answer before I hand it over to you, Kudzai. So I think I would say like there's some the image that we presented. This feels like people who do not have a deep dive understanding of broker architecture, etc. Because like each broker and each edge has a built-in persistence layer. The processing layer itself is like the agents that are processing the data in flight of atop the broker and the edge, and the application layer is the MQTT itself, because we are sending a data agnostic payload. So we are not processing anything at the cloud or at a data center. It's being processed in the factory, but you do need some guardrails around governance, and you need guardrails around, like, you still need to have a metadata information being sent in and out. So those are the things that are centralized, and everything else is distributed. And because I think like at this point I'll hand it over to you. So please like walk them through how would you answer that?
absolutely. Yeah. So Helen, I think the most important thing to understand there that there's two kinds of intelligence. There's real-time intelligence, and then there's sort of like your more long-term kind of like intelligence, right? So there's situations where just getting access to the real-time data. So if I want to see what is the current rate that this production line is currently running at, and what other equipment is actually what are the equipment states? Is there an equipment that is starved, right? And what was the last 5 states? So you can combine all of that information to actually create intelligence through data that is actually happening in real time, right? So you don't need to actually persist that, and then you can persist it to generate some kind of intelligence later. And by the way, also on that data intelligence layer that I mentioned, we do have some form of ephemeral storage. It's not a persistent layer where you can actually act as a database, but rather, because the concept of unified namespace only returns one message on a topic, but intelligence layer allows you to sort of like buffer. So you can say, from this topic, I want to keep 500 last messages, or I want to keep 300 last messages, and then you can do aggregation. What was the minimum in the past 2 hours? And so this is all real-time intelligence that you can generate without having persisting it at the data center.
We have one more minute, and I think there was another question that I cannot seem to find anymore, but there was a question: how do I get my data from HiveMQ Edge? I I understood you want to get the data out of Edge, and you're already bringing in the operational data via MQ Edge. So the answer from my side would be that you simply use an MQTT bridge to get the data into like a broker where you're aggregating the data, and then using the extensions, you can send this data into any IT system of your choice. Kudzai, do you want to add something? I'm not sure if Kudzai is. Are you still there? Yeah, I think there's some internet issues.
Yes, I'm still here. Can you hear me? Okay. Yeah, I might have problems with my camera, but yes, no, I think you addressed it very well. So it's still MQTT, it's still an open ecosystem, so you can pretty much plug any system that understands MQTT into HiveMQ Edge and get all of your data for whatever use case you want.
Okay. Then I think we are run. We are finished with the time. We, like, my colleague opened up the survey, so please take time to answer the survey. It really helps us to improve it. And again, thank you for being part of today's webinar, and thank you for listening us. I hope this was very informative and insightful for you. If you have any questions, please feel free to reach out. We would love to engage more with you guys. And please block the dates in September, early September, for our next webinar, where we deep dive into our product and our platform and how we solve all these things that we talked today in the webinar. So Yeah, that's all from my side. Kudza, any parting words before we close?
Thank you so much to everyone who attended this session today. Really appreciate it. Have a great day.
Yeah. Thank you from my side as well, and have a nice day. Bye bye.